Okay, this is organic chemistry class. This is a special class, a request made by some students that a class like this should be done for them because of their forthcoming exam. So if you are new to this channel, kindly subscribe and also click on the notification bell icon to know when I upload a new video. All right, without wasting much of your time, let's get started. All right, now before I start explaining this organic chemistry, what it's all about, now these are the things that I need you to do for me. First of all, I would like you to place or rotate your phone in a landscape mode so that you can watch this video very well, like in a full scale, full screen. Then also, you can also play this video. It's advisable you should play this video using an earpiece so that you can get all the audio very well and hear exactly what I am saying in this class. Then you can also do one more thing to bring out your writing material to take down all the information that I'm saying. Now, I'm not here to teach you organic chemistry the way your chemistry teachers or your school teacher taught you organic chemistry. I'm here to break down things. And this video is going to come in many various parts. Part one, this is going to be the part one. So this part is the introductory part. So I'm going to do a lot introduction in this section because it's not possible for me to break down or say everything or teach you everything that you need to know in this. So this is for those of them getting ready for JAMB and also those of them getting ready for WAEC. Then for this exam of a thing now, they mostly focus more on IPAC nomenclature. So I'll be spending more time on IPAC nomenclature in the subsequent parts and so on. All right, now let me not waste much of your time. Let's start with what organic chemistry is all about now. So first question is, what is this organic chemistry in question? What is organic chemistry now? The first thing that you need to know is that, first of all, is that organic has to do with living things. It has to do with living things. Take note of that. But when you talk about this organic chemistry, what is it now? It is a chemistry that has to do with what? Chemistry involving what? Carbon and its compound. Chemistry of what? It's a chemistry of carbon. It is a chemistry of what? Carbon and its compound. And whenever I say carbon and its compound, what do I mean by now? We are going to be talking about the compounds of and its compounds. We are going to be talking about the compounds of carbon, but we are going to exclude the following. So excluding. So in this organic chemistry, even though we are talking about carbon and its compound, will be excluding the following. What are we going to exclude now? We are going to be excluding the triiosocarbonate 4 of its. We are going to excluding its triiosocarbonate 4. So let's put its, excluding its triiosocarbonate 4 carbonates. Yes, carbonate 4. So we're going to exclude its triiosocarbonate 4. And when I say something like triiosocarbonate 4, what exactly do I mean by that? Let me just give an example. Something like we have something like this, sodium triiosocarbonate 4. You see something like sodium triiosocarbonate 4. Its triiosocarbonate 4 belongs to the inorganic chemistry, not part of organic chemistry. Okay. Now the next one I'm going to talk about is we are going to exclude its oxides. We are going to exclude the oxides of carbon. Oxides of carbon. An example of oxides of carbon that we have is what? What do we have now? We have something like CO2, carbon 4 oxide, or carbon 2 oxide. We are all going to exclude what we call its carbides. We're also going to exclude what we call its carbides. An example of the carbides of carbon that we have is something like sodium carbide. We have something like sodium carbide or even calcium carbide. So all these ones that I mentioned last, from here, the triiosocarbonate, for all these belongs to what we call the inorganic. They are not part of the organic chemistry. So the organic chemistry we're going to be talking about is going to exclude this one that I just circled now. They are not part of it now. So let's continue with what we have now. Now, we basically have to remember that carbon has one unique feature. What feature does carbon has? When you talk about this now, carbon has a particular unique feature. And what feature does it have now? So carbon has a unique feature. So let's say carbon has a unique feature. And what feature are we talking about now? Carbon is the only element that has the ability to do what? To form straight chain, like to be able to bond with itself, to form straight chain. So it can bond with itself, unique property. And when I say unique property, let me put this in properly. So carbon has a unique property. So what is a unique property now? The unique property carbon has is what we call catenation. That unique property is what we call catenation. And what is carbon catenation all about now? Ability of carbon to bond with what? With itself. So we have it as what? Ability. Carbon has the ability to what? Ability to bond with, okay, with another carbon, okay, another what? Another carbon to form what exactly is it going to form? To form stretch chain. It can form stretch chain. It can form what again? Branch chain, branch chain. You can even form something like a double bond, triple bond, so and so on. So that ability that it have to be able to what to bond with another carbon covalently. You know, the process that the bond is going to be a covalent bond, covalently. So the ability to bond with another carbon covalently to form stretch chain, branch chain, etc. is what you call what? It's called a catenation. That process is called okay, it's called catenation. So this is one feature carbon has. You might be wondering what exactly do we mean by that? If you look at or if you study other compounds, or sorry, other elements can only bond with itself once and stop, probably something like this, nitrogen for nitrogen and so on. But for carbon, it can form stretch chain. Look at this. It continues to bond with itself. So this is what you call chain. So this is what you call stretch chain. Please, I would like you to take note of one thing. Any comment that I made, please take note of it. Now, I made a comment here and I call this, what did I call this in now? I call this stretch chain because with time I'll be mentioning the word chain in this video. I'll be using the word chain so that when I use the word when I use the word chain, you will not be confused or wonder what is chain. I've already drawn to you now what chain is all about. You can see the way carbon chain is being formed now. Chain, carbon to carbon, carbon to carbon, carbon to carbon, carbon to carbon. So this is what you call a chain. So this is carbon a chain. Please, this is different from this now. This is not a chain. If I include something like hydrogen here, this is no longer the chain. The hydrogen, the carbon to hydrogen is not the chain. So the chain that we'll be talking about is carbon to carbon atom, like the carbon to carbon, carbon to carbon. That is carbon to carbon, carbon to carbon, carbon to carbon is what we call the chain. So this is a straight chain. So if we have something like this now, how about if we have something like this? Let's say we have something like this and we have another one like this. This is what we call a branched chain. You can even have an addition like this. This is what we call a branched chain. So if you like, if you look at this now, this is a branched chain. Branch in the sense that the carbon to carbon atom, it's not going straight forward, like it's not going straight. So you see that you can have something like this. You can have something like this. You see, this is a straight chain. Then the remaining one is the branch of that main chain or that straight chain that we have. So the remaining ones that we have here, these ones that are not included in the chain are the branches of the main chain. And remember the way I drew the chain now, these are stretch chain. So I needed to know the difference between that because when we move deeper into this video, we'll be commenting or be saying something like that. Okay, now since we are aware of this, now the next thing I'm going to be talking about is I'll be talking about what you call I'll be talking about what you call, let's clean up this. Let's talk about the classification of this. Let's talk about the classification. Let's classify this now of these organic compounds. Now, organic compound can be classified into two. I basically do classify this organic compound into two. Your person or someone that is actually teaching you can also classify it in another way. So let's look at the classes. I basically classify it into two. First of all, this organic compound can be classified into two. First, we have what we call classification classes, or let's say, okay, let me put it in brackets here and call it classification of organic compounds. So let's talk about classification of organic compound the way I'm going to classify it. First, we have what we call the hydrocarbon. We have what we call the hydrocarbon. You might be familiar with this word hydrocarbon. Hydrocarbon is also called hydrides of carbon. It's the same thing as called hydrides. Hydrides of what? Of carbon. And when they say hydrides of carbon, it means that for this category, we only have two things. And the two things that we're going to be having in this category is only carbon and what? Hydrogen. So that's what we call the hydrides of carbon. Then the next part is what we call the non-hydrocarbons. The next one is what we call the non-hydrocarbons. Now, the non-hydrocarbons means that they have hydrocarbons. The non-hydrocarbon mean that I can also call them heteroatoms. I can call them heteroatoms. Heteroatoms. So it means that this one in question, what do they have now? This one, they have more than carbon and hydrogen. They have more than carbon and hydrogen. So under this now, what do I have under the heteroatoms now? I'll list out what I have, some of them. Okay, let me start with the heteroatoms now. Under the heteroatoms, I have what we call the alkanol. I have what we call the alkanol. Please take note of this because during the course of studying or during the course of this lecture, I'm going to be breaking down all, in fact, we're going to cover all these things that I'm listing here. So we're going to have what we call the alkanol, commonly known as what? Alcohol. We have this as alkanol. So the next one is what we call the alkanal. We have what we call the alkanal. The alkanal, commonly known as what? Aldehyde. So this is commonly known as the aldehyde. Then we also have another one known as the alkanoids. We also have what we call the alkanoids. We have the alkanoids. The alkanoids, commonly known as what? Ester. It's called ester. Then we also have another one called the alkanone. We have alkanone. We are going to cover all this. Please stay to the end of this video because in series or one of the series of this video, I'll be covering all these things one after the other. So we have what we call ketone. This one is called the ketone. Then we also have another one known as the alkanoic. We also have what we call the alkanoic. Now these ones are called the alkanoic acids. You know, it's called alkanoic acid, not alkanoic. So these ones are called the carboxylic acids. They are called the carboxylic. They are called the carboxylic acid. Carboxylic. They are called the carboxylic acids. So then we also have what we call the amides. But this time around, this amide, let me just call it alkanamides. Al. This is Al. Sorry, let me put this properly. So sorry, excuse me. This is okay. So we have it as alkyne amide. So this is what I am referring to, what we call the amides. We're talking about these amides. So we also have what we call the alkanamine, alkane, amine. Okay, that is, I'll be talking about the amine here. Okay, so we also have that. Then we also have what we call the alkyoxys. Alkyoxy what? Alkane. These ones are called the ether. Okay, we have this to be the ether. Then the last one is what we call the amino. Okay, we have what we call the amino what? Amino acid. Out of all these things that I've listed out now, which amongst them can you easily say that you know? So we have this is the first one, alkanol. What is the formula for alkanol? Because you expected to know the formula of all these things. So what is the formula for alkanol? General formula for alkanol: alkanoids, alkanone, alkanoic, alkanamide, alkanamine, and alkyloxy and amino acid. You expected to know their various formulas. Okay, so but like I said, that if you keep sticking around with if you stick to the end of this video or to my second part of the video or other parts of my videos, I will explain and give you the general formulas of all this. You need to know these things very well. And by the time you know them, any question that pops up or comes up in your examination, you can easily answer them. You know, all these things are not difficult at all. Your JAMB question or your Y question, they are just trying to make or establish if you understood the concept very well. So coming to this hydrocarbon, you know, hydrocarbon, we always say that it only have a hydrogen and carbon and hydrogen. And under hydrocarbon, we have what we call the aliphatic. So let's classify we have what we call the aliphatic, and we also have what we call the aromatic. I believe Some of you must know this that I'm talking about. And under aromatic, I have what we call the benzene under here. Okay, I have benzene under here. Then under the aliphatic, now I'm going to still divide it into two. I'm going to have, what am I going to have here now? I'm going to have the acyclic, those of them that are stretch chain. That is what I mean by the acyclic. And I'm also going to have what we call the cyclic hydrocarbons. Cyclic, or those of them that are what? That forms ring, like they form the ring. And examples are start from what we call the cyclo. Let me change my barrel so that you see what I'm having here. So let me clean up this first. So example of that is what we call the cyclopropane, cyclobutane, cycloheptane, and so on. So let's proceed with the next one. So the next one I'm going to be talking about, under the acyclic, I'm going to have three of them here. So what are the three categories that I'm going to be having under this acyclic now? So the stretch chains, those of them that form the straight and branch chain. Yes, the acyclic, they form basically two things. What they form is what you call the acyclic. This acyclic here basically form two things. What they form is what you call the straight and the branched chain, whereas this cyclic form rings. So let's see this now. So under this now, under the acyclic now, we have, what do we have here? We have what you call the alkane. Sorry, alkane, Al, this is alkane. Then we also have alkane, commonly known as the paraffin. It is commonly known as the paraffin. So paraffin, this is N, this is N, paraffin. So we also have what we call the alkene, commonly known as the olefin. Then we also have what we call the alkyne. We also have what we call the alkyne. So the alkyne, commonly known as what? The alkyne, this is K, commonly known as what? Your acetylene. Acetylene. So these are the things that we have under this section now. So the next thing I'll be talking about is, first of all, before I start analyzing each of these, before I start pointing out on each of these, all these things that I have here, because what I'll be talking about in this video is, I'll be talking about in my subsequent parts of these videos, I'll be talking about this alkane, the general formula for alkane, IPAC nomenclature for alkane, the isomerism, alkane, the same thing, alkyne, the same thing, and other ones that we have here. So these are the things we'll be talking about in this video. Like I said, this video is going to, this video is going to come in series, part 1, part 2, part 3, part 4, and so on, so that I'll be breaking down each of them. So in each part, I'll be explaining each of these one after the other. So this is just an introductory part of it. So before I move over to explaining each of these one after the other, I need to understand one thing about this organic chemistry. We have what we call the homologous series. So, these are the homologous series now, whereby they have members. This alkane has members under it. Alkene has what we call members under it. Alkyne has members. So these are the homologous series now, where each of them has what we call members under them. So, and this member they have under them now, they basically have start with one thing. Each of them has one feature. And what feature do they have now? They have a feature of number of carbon atoms in them. So that is exactly what I'm going to be talking about in my next in the next slide. I'll be talking about the number of carbon atoms in them now. Someone might be wondering what I mean by the number of carbon atoms that we have in them. Look at this. We have alk here. Watch closely. You observe one thing. You have alk here. You also have alk, ALK. Then look at all these that I have here now. Take close attention so that you observe what I'm saying, because I said in this video I'm not going to be teaching you this like your regular teacher. So look, pay attention. See, we still have what we call arc. So arc. Now, this arc of a thing, from the way I'm going to explain it now, I need you to understand one thing. That this arc of a thing is kind of representing the number of atoms, like the number of carbon atoms that these have. So if it has one carbon atom, what do you start it with? If it has two carbon atoms, what does it mean? If it has three carbon atoms, look at it. This still have the same arc. So you need to take note of this information. If it has three carbon atoms, what does it simply mean? So let me explain that now. Let me give you that, or break down this in my next class. So in my next slide now, this is exactly what I'll be talking about in my next class, so that you understand. So let's go over to this. Let's clean up this, and or better still, let me go over to the next page. Okay, let me create a new page. Okay, So sorry. Okay, so let's see. Now I say that before I go over to talking about, because I know what they normally do is they will tell you you should know the functional group. But before you talk about the functional group now, there's one key thing that you need to know: the number of carbon atoms. Number of carbon atoms. Carbon atoms. When you talk about number of carbon atoms, I will explain what I mean by number of carbon atoms. This may not be the proper heading, but let me explain what I mean by number of carbon atoms now. Now, if you look at this now, if the organic compound, listen carefully, pay attention. I said that if the organic compound that we're about to name has what we call one carbon atom. Let's look at, okay, let me put this in properly. Let me talk about carbon atoms that it has. So assuming we say that, let's look at the number of carbon atoms, number of carbon, sorry. This is number of carbon. Okay. So then let's talk about the name that we call it, the name. So let's look at this way. So if the organic compound has one carbon atom, please, one carbon atom, it's called meth. You call it meth. So if you are looking at this now, look at the organic compound closely. It depends on the number of carbon atom, which is kind of, I was trying to say that they have one thing in feature, and one thing they have in feature is what the word arc. So which means that you have to study in every organic compound that is given, or any structure that is given to you. The first thing that you need to do is study the number of carbon atom it has. If you look at it and you only saw one carbon atom, you will start with the word meth. So each of the arc, whether alkane, alkanol, any organic compound that you have. So we have the two carbon atom. Two carbon atom means what? You start with the word earth. Then how about three carbon atom? Three carbon atom, if it has one carbon atom, it just simply one. So two carbon atom, it might just have something like two carbon atom this way. So for three carbon atom means what? Now you start with the word prop. So how about four carbon atom? Four carbon atom, you start with the word boots. Boots. Sorry, this is boots. So how about the fifth? This is boots. Let me write this properly so that you won't be confused. Boots. So how about five carbon atom? Five carbon atom is what? Pent. So six carbon atom is what? Hex. Then seven carbon atom is what you call hept. Is hept. Then eight carbon atom is what you call oct. Then how about nine? Let me clean up here. Okay. So how about nine carbon atom? If it is nine carbon atom, what will you call it now? You call it non. Then 10 carbon atom, we are going to call it what now? We call it deck, and so on. So let's stop at this place. So we're going to stop at 10 carbon atom. We're not going to go over to 11, 12, and so on. So this is the first thing that I needed to know. Now, since you've understood what you call the number of carbon atoms, so what exactly are we going to be talking about? Because I will still make use of this number of carbon atoms when I start mentioning or start naming all these organic compounds. So I'll make use of them. So before I talk about that now, let me start from the first part of the chemistry that we have here now. Let's start with what we call the So let's start with what you call the hydrocarbons. Let's start from hydrocarbons. So, I said we're going to be going back to that again. So let's start with what you call the hydrocarbons. So let's look at hydrocarbons. So the hydrocarbons that we have, you need to pay good or close attention to what I'm about to say here. So for the hydrocarbons now, what exactly do we have now? We are going to talk about the, okay, let me call here the homologous series. Let's see here as your functional group. Then final one, functional group. Then we now talk about the formula. Okay, the general formula that it has. General formula. So let's pay attention to this. Okay, so sorry. Okay. So let's see this. And okay, now, so the first thing we're going to talk about here is what we call the alkane. Let's look at the first member known as the alkane. Alkane, that's number one. Well, basically, it doesn't have a functional group, but let's use a single bond to represent that. So the general formula for alkane is given as what? CnH2n plus 2, where this your n start from here, from 1, it can be 2, it can be 3. This your n now determines the number of carbon atoms we're going to have. Remember that I told you that this hydrocarbon always have two things. Look at the formula. Pay attention to the formula. It only have two things, which is what we call, it has what we call carbon and hydrogen. That is only two things that are there, whereby this N just represents, it can be 1, it can be 2, it can be 3, and so on. So if it starts from one carbon atom, it has it's going to call methane. I'm going to come back to this so that you understand properly. So the second one we're going to talk about is what we call the alkene. Alkene has what we call a functional group of what? Double bond. So if you want to identify your alkene, you use your double bond. So the formula for alkene is going to be CnH2n, is going to be CnH2n. That is H2n. That is for alkene. Then the third one is what we call the alkyne. The third one is what we call the alkyne. The alkyne has a triple bond, and this is going to is given as CnH2n minus 2. This is the general formula for these hydrocarbons that we have here now. Now, before I go over to what we call the non-hydrocarbons, before I talk about the non-hydrocarbons now, I would like to mention one thing now. Since I've already given out this omega series, and I've also given out their functional group and also their general formula, before I go over to the non-hydrocarbons now, let me quickly show you their members, how their members are being written, or how their member shows up or looks like, each of them. So let's take a look at this. Okay, so let's look at the first one that we have is what we call alkane. The first one that we have is alkane, and the general formula of alkane is CnH2n plus 2. So that is the general formula for alkane. So it means that if I'm to start with n is equals to 1, I'm going to have it as C1H2 bracket 1 plus 2. And this is going to give me what now? Then I'm going to have it as C1 is the same thing as CH, 2 times 1. That let me put out the pointer. 2 times 1, or 2 times 1 is going to give me 2. 2 plus 2 is going to give me 4. So basically, I'm going to have here C4. So the first member of alkane, let's look at the members that we have. The first member of alkane is going to be what? The first members that we have here is what we call CH4. So this CH4, this is number 1. This CH4 is called what? What do we call this CH4? This one is called, this is for alkane. This one is called methane. Why methane? One carbon atom is called meth. Pay attention to what I'm about to do now. One carbon atom is called meth. So, and if you look at this now, look at the structure of this, the methane. The structure of this methane is going to be like C. This is the structure of this methane. This is the structure of this methane. This is how it's going to look like. So one carbon atom is methane, is called, this is arc, showing the number of carbon atom. So one carbon atom is meth. Then you're going to end it with the ane family, A and E methane. So we have the next one. The second one is going to be N is equals to 2. N is equals to 2. So if you solve this C2, H2 bracket 2 plus 2, this is going to give me what? This is going to give me C2, H. 2 times 2 will give me 4. 4 plus 2 is going to give me 6. So this is going to be C2H6. And because of two carbon atom, what will I say now? This two carbon atom, because of presence of two carbon atom, what will I call it? I will say ETH for two carbon atom. And this belongs to the ane family. I will write A and in ethane. And the structure is like this C2 carbon atom. Then I'll complete the rest. 1, 2, 3. You know, every carbon that you have, every carbon will have maximum number of stroke around it, and the maximum number of stroke that's supposed to be around every carbon is how many? 4. Please take note of this formation. I say that for every carbon that you're going to see in your organic compound, the maximum number of bond around that carbon is going to be how many now? It's going to be 4. So if it is beyond 4, please remove 1. So this is because each of these bond contains 2 electrons. So we have here to be 1, 2, 3, and 4. So this one is complete. I have hydrogen. You can put hydrogen here. You can put hydrogen here. So how about this one? How many do I need to complete it? I have 1 already for this. So I'll complete the rest. I have 1. Then I'm going to have another one 2. And I'm going to have another one at 3. So it's now complete. I have it as 1, 2, 3, 4 for this carbon. So that is why we are going to have it as C2, 2 carbon. We are having it as C2. We have the 2 carbon. And we have the 6 hydrogen, which is 1, 2, 3, 4, 5, 6. So that's why we have it as C2H6. So I want to write the next one, but the next one, I may not basically write the next one using this formula again. Let me change the system I'm going to use to write the next one. I know that each member is differentiated. I mean, each member differs by what we call the methylene group. So and the methylene group is given as CH2. I want to write the next one. So I'll just say plus CH2. So C2 plus C will give me C3. And H6 plus H2 will give me what now? H8. So the next one is going to be what now? What is going to be the next one? So number 3 is going to be C3, H8. And this is called prop. Prop because of 3 carbon atom. Ane because it belongs to alkane family. So if I'm to sketch this, it's going to be 1, 2, 3. I have it as 3. How many stroke is going to be around this carbon? Now let's complete it. This carbon is sharing 1. This carbon is sharing 1 already. So I'll add extra 3. So 2, 3, and what? 4. So this carbon is complete. I will just put it this way. It's complete. How about this carbon? This carbon has only 1 and the other one at the back, 2. So how many do I need to complete it? 1 on top, which is 1, and 1 below, which is 2. How about the last one? This one is same thing. I have it as 1, 2, and what? 3. So if you count all together, if you count all this all together, you have it as 1, 2, 3, 4, 5, 6, 7, and what? 8, which also corresponds to what I have here now. All right, so let me just stop here because I believe that you understood what exactly I'm doing. So if I'm to write the next member, next member, I'll just say, you just add, what will you add? Just add your methylene. Instead of you to start solving with the formula, just add your methylene group, which is CH2. So that is going to give me what? What is it going to give me? It's going to give me C4H10. So that is exactly what I'm going to do. So I'll continue with that. That is for the alkane family. Okay, so for the alkene family, remember I've been doing this and I also included the structure. Now this is the name, here is the name, and here is the structure. And the structure that I have here is called common structure. Please take note of this. This is called common structure. With time, I will also expose you to what we call the condensed structure and staggered structure. Because when you come to this exam, JAMB always asks question, or some exams, they always ask questions they don't basically use these common structures again. They use what we call the condensed structure and the staggered structure. So for now, since we're still learning, we're still beginning, let's continue with the common structure before we now talk about the staggered structure and the condensed structure. So the next family I'm going to talk about is what we call the next one I'm going to talk about is what we call the alkene. So let's quickly talk about the alkene family. So the next family is what we call the alkene family. We're going to talk about the alkene, alk. So if you put the number of carbon atom, you're now ending with in. So number of carbon atom, one carbon atom, we say this, like at in, and so on. So that is alkene, and the formula for alkene is CnH2n. So that is it for the alkene. Let's talk about the homologous series. Let me list out the members that we have here, the members that we have over here. Then I'm going to talk about aside the members. So let's look at this. Let's look at this. So let's look at their names. Let's look at their names, and let's look at the structure. Let's look at the structure as well. So let's look at the first member. That the first member of alkene is what you call ethane. So which is, if you calculate it now, the N for this one will not start from 1, it will start from 2. So which is going to be what now? C2H2 bracket 2. So which is what? C2H4. So the first member of this one is going to be C2H4. This is the this is the formula that we have, a C2, and the name of this one is going to be what now? Ethane. The structure is going to be what now? C. Because alkane family has a functional group of double bond, you put double bond. How many hydrogen do I need to complete this one? I have 2 here already. I need extra 2, which is 1 and also 2. So I have it as H here and also have H here. This carbon is complete. Then for this one, I'm going to have 1 and extra 2. So I have it as 1, 2, 3, 4. This is complete. That is for your 18. So the next one, I may not basically use the formula again. I've explained to you how to use the methylene group, so which is CH2. So the next one, I'm going to add CH2 to it to get my next member. So which is what? C3H6, and this one is going to be what now? Propene, meaning that it will have 3 carbon atoms. So I'll just say 1, 2, 3. Look, I pay close attention to where I'm going to be drawing it now. The double bond, where is the double bond going to be? The double bond can be anywhere. Remember, I told you that in my subsequent class or in my subsequent series, I'll be talking about their isomerism, how to do that. So I can place the double bond anywhere. I can choose to place it here, or I can also choose to place it here, any place. So I have this to be here. So let me complete this one. I have this carbon has 2 already. So I need extra how many now? 1 and extra what now? This is 2. This carbon is complete. For this carbon, I'm going to have it as 1. I have 1 here. You know 1 is going to be here most 2. So you see that 1, 2, 3 for this carbon is also complete. For this carbon, I'm going to have it as 1, 2, 3. So I'm going to have 1, 2, 3, and 4. So it's complete. So this is called propane. Under the IUPAC nomenclature, you'll be hearing something like prop 1 in, prop 2 in, and so on. Just an instance. So for the third one, I'm going to stop at the third one. The third member is going to be what now? C4. H what this time around? Tell me. It's going to be H what? H8. So I hope you know how I got H8. Just add your CH2. Add your CH2 to it. So if you add your CH2, I have it as C4, H8. And this is going to be what now? Boots in. So the position of the double bond, where is going to be the position of the double bond? Let's look at the structure. The structure is this way: C, and C. How many carbon do I have here? 4 carbon. So the double bond, where is the double bond going to be? The double bond can be anywhere. That is when you talk about the isomerism. It can be at the first carbon atom, second carbon atom, and depending. But for now, let me leave it here. So I'm going to complete this one. I'm going to need extra 1 here. I'm going to need extra 1 here for this carbon to be complete. For this one, I'll put it here. So I have 1, 2, 3 for this person. Then I'll place 1 here to be 4. So for this, I'm going to have 1. I'm going to have 2. Then I'm going to have 1 here. So it's going to be 1, 2, 3, 4. This is complete. Then this one is going to be what now? 1, 2, 3, and what? 4. So I hope you are paying attention to see the way I am doing it. So gradually you understand this, the way it's being written. So, and like I said before, this is called, what do I call this in again? This structure that I'm currently drawing or I am using here is called a common structure. Your examiner most times don't use common structure. They use what they call the staggered structure, and they use what they call the condensed structure. I'll also show you that so that you will know how to convert the condensed structure to common structure if you are finding it difficult to use a condensed or staggered structure. Okay, so let's go over to the final part of the hydrocarbons, the final part of it. So the final part of the hydrocarbon, we're going to have what we call the alkyne. So we're going to have what we call the alkyne. The alkyne is giving us CnH2n minus 2. So then for this alkyne, basically we're going to talk about, let's look at their members. I'm going to talk about their members. Then I also talk about their names. I'll present to you their names. So we talk about their names. IUPAC nomenclature. When I say name, I'm talking about what we call them. So the names and their structure. And you know exactly the structure I'm talking about. This is the common what structure. So the common structure, that's exactly what I am using in this video for now. So I'll also show you the other types of structures with time. So now looking at this now, we have first thing first, what the first member of alkane always start from 2, doesn't start from 1. Like alkane, it start from 2. So since it start from 2, what do we have here now? We are going to have it as n is equals to 2. I'm going to have it as C2H2 bracket 2 minus 2. So this is going to give me what now? 2 times 2 will give me 4. 4 minus 2 is going to give me C2H2. So the first member of alkane is going to be C2H2. And because it's 2 carbon atom, I'll call it what now? Earth. I'll put YNE because it belongs to the iron family, YNE. And what is going to be the structure? I'm going to have 2 carbon atom, and the functional group for alkyne is triple bond, 1, 2, 3. How many do I need to complete for this carbon? I need only 1 because 1, 2, 3, and 4. So how many do I need to complete this one? Just only 1. So that is for this one. Then the next member is going to be what now? Using your methylene group, add your methylene, so I'm going to add CH2 to get my next member if I want to get the next member. So if I add, this is going to give me what now? C3H4. So this is C3H4, and this is called what? This is called propine. This is called propine. I hope you know why it's called propine. Prop because it has 3 carbon atoms. That's why it's called propine. So I'm going to have it as 1, 2, and 3. The triple bond can be anywhere for now. Since I'm going for the common structure, I'm not talking about isomerism yet. So I'll just put it anywhere. Let me put it here. So I only need 1 for here. So because this carbon is complete, I have it as 1, 2, 3, and 4. For this carbon also have 1, 2, and 3. So it only need 1 to be complete. For this carbon, it needs extra 3 because 1 is already here. I have 1, 2, and 3 needed. So this is now complete. So this is what we call the propine. Then the next member is what we call, add again, is going to be C4H6. And this is called butane. So butane, for butane, I'm going to have it as 1, 2, 3, and 4. 1, 2, 3. And then I'll put 1 here for this one. Then I'll put 1 here. So this carbon is, I don't need to put extra because if you count, I have 1, 2, 3, and 4. It's not complete, so I don't need to put extra hydrogen. So I will now put 1 on top here, 1. I'll put 1 here, 2. Then this one will complete it, making it for 1, 2, 3, and 4. So we also have 1, 2, and 3. 1, 2, 3, and 4. So we have hydrogen, we have hydrogen, and we have hydrogen. So this is for your butane. So we also have other members. We have pentane, hexane, and so on. But I'm not going to be talking about all these ones here right now. So it's only when we move over or go deeper, we talk about it now. All right, now in my next series now, I will be talking about the non-hydrocarbon. I also show you their structures. And for the non-hydrocarbons, please, I would like you not to miss that one. I would like you to make sure that you watch the videos on the non-hydrocarbons, because that non-hydrocarbon is the key thing. The non-hydrocarbon is exactly where students always have a challenge, because your examiner, they won't be asking questions under this okay, they do ask questions under this alkyne and alkane, but most times they also push it towards the non-hydrocarbons because they know that students don't understand that non-hydrocarbons, how to name them very, very well. So in my next series, I'll be talking about the non-hydrocarbons. So that is it now. Okay, so remember, don't forget that if you are new to this channel, don't forget to subscribe and also like this video. Then if you're ready for the next part or for the second part, please, I would like you to type in the comment section next for you to be able to get my the second part of it. Please do so. Also share this video to your friends so that they can also benefit. All right, I will see you in the next one. Thank you.